Hello. Today we are going to discuss about the spectroscopic technique or spectroscopic technique. As we say, is a method of analysis in which the matter or the analyte is analyzed based on the interaction of the matter with the electromagnetic radiation. Now, for the spectroscopy, what kind of electromagnetic radiations are used? Based on that, there are different types of spectrophotometric techniques or spectroscopic techniques. In this topic, we are going to deal with the UV visible spectrophotometry because here UV visible radiations are used to determine the analytical parameters of the analyte. The spectrophotometer, UV visible spectrophotometer, are of two types. One is called a single beam spectrophotometer and another is called as a double beam spectrophotometer. Here we are going to discuss about the single beam spectrophotometer. The single beam spectrophotometer or double beam spectrophotometer both are working on the principle of Beer's law and the theory of electronic transition. What is Beer's law? Beer's law is a law which deals with interaction of electromagnetic radiation. What interaction? The absorption of electromagnetic radiation. So it states that absorption of electromagnetic radiation is directly proportional to the concentration of the media through which monochromatic light is allowed to pass through. Okay. Then the theory of electronic excitation is the theory which deals with the excitation of the electrons from ground state to the excited state. Now whenever any matter is allowed to bombard with the electromagnetic radiation or electromagnetic radiations are allowed to fall on that matter, then there is an electronic excitation, especially in case of UV visible spectrophotometry or UV visible radiation from the bonding molecular orbital to the anti-bonding molecular orbital. Here bonding molecular orbital can also be called as a lower energy orbital, while anti-bonding molecular orbital will be called as a higher energy molecular orbital. So here, electron will excite by absorption of UV visible radiation from bonding to anti-bonding molecular orbital. Now this is the diagram of a single beam spectrophotometer. The basic component of the single beam spectrophotometer are the source of light, then monochromator, sample cell or sample holder, detector, amplifier and readout device. These are the contents or the components of the single beam spectrophotometer. One by one we will discuss each component and the properties of each component. Now we will first start with the source of light. In case of UV visible spectrophotometry, we need the electromagnetic radiation, that is the UV visible radiation, ranging from 200 nanometer to 800 nanometer. Now these two radiations, that is the UV radiation and the visible radiation, cannot be completely obtained by the single source of light. So the source of light should be the light source which will emit the light of efficient or sufficient intensity. It should emit the light with broad range of UV visible spectra. Okay. Now here in case of UV visible spectrophotometer, tungsten filament lamp or tungsten halogen lamp are used. Now this tungsten halogen lamp or tungsten filament lamp emits the light of visible and UV radiation ranging from 330 nanometer to 780 nanometer, or we can say from 350 nanometer to 780 nanometer. Okay. While along with this tungsten filament lamp, deuterium or hydrogen lamp is used. Now this deuterium lamp or hydrogen lamp emits the light ranging from 160 nanometer to 360 nanometer. In case of a analytical parameter, if you require the light of full UV visible range, then both the light source can be used at the same time, or if if you want the UV light, we can use the deuterium discharge lamp, or if you want the visible light only, then we can use the tungsten filament lamp or tungsten halogen lamp. Then monochromator. Now we know that whatever the source of light we are using, it is a polychromatic source of light. Now this polychromatic source of light cannot be used to analyze the analyte by using the UV visible spectrophotometer. So we need the monochromatic light, and the monochromator is the device which converts the polychromatic light into a monochromatic light. Now here the monochromatic light doesn't mean the light of a single wavelength, but it is a packet of light having wavelengths of very narrow bandwidth. Okay, then this monochromator is again having certain components. There are lenses, mirrors, slits, and the wavelength selector. As you know that lenses will be used to focus the light at certain point. Mirror will be used to reflect the light or to deviate the light or to show the path to the electromagnetic radiation. Then slits. Slits are of two types. One is called as an entrance slit, another is called as an exit slit. Now the entrance slit is placed between the source of light and the wavelength selector, and this entrance slit will allow the passage of specific portion of radiation into the wavelength selector, while exit slit is the slit which is placed between the wavelength selector and the sample cell or sample holder. It will allow the passage of monochromatic light from the wavelength selector to fall on the sample holder, which is containing the sample of analysis. Then further, wavelength selector. Now this wavelength selector is the actual monochromator which will convert the polychromatic light obtained from the source into a monochromatic light. There are three types of monochromator or wavelength selector. One is called as a filter. Filter is nothing but the colored plates, or we can say colored films which are clubbed into the glass plate. Now suppose we want the light of red wavelength, so we can use a red color glass and that will give us the light of red color. But here whatever the light obtained by using this filter is having very broad range of wavelengths, so it is not of that much useful for the UV visible spectrophotometer to get the exact results. Okay. Then prism. As we know that a prism is a transparent optical material, and this transparent optical material is having ability to disperse the light into different wavelengths. Now by using this prism we can disperse the light, and this dispersed light can be converted into individual wavelength light by using the collimator. Now this prism are of two types. One is called as a glass prism and another is a quartz prism. If you are using in the colored region, that is the visible region, then glass prism can be used, and if you are using the sample which works in the UV region, then quartz prism can be used. The wavelength obtained or the monochromatic light obtained by using this prism is of very narrow wave range, so it is of useful to be used in the UV visible spectrophotometer. Next one is the diffraction grating. Now diffraction grating is an optical device in which large number of alternately placed parallel slits and opaque areas are there. Now we know that slit is a device through which we can pass the light, while the opaque areas will not allow the light to pass through. Okay. Now when the light will fall on this diffraction grating, then there will be a diffraction of light. There will be a constructive and destructive interference, and due to this constructive and destructive interference we will have a dispersion of light and we will get the monochromatic light from the polychromatic source of light. The diffraction gratings are of two types: transmission grating and reflective grating. In case of transmission grating, if we take a glass plate and plot n number of parallel lines by using the diamond point on that glass plate, then the lines will act as an opaque area, while the distance between two light lines will act as a slit, and this we will call as a transmission grating. Now whatever the transmission grating which are used in the labs or in the instrument, they are the dummy one. They are obtained from the main transmission grating. Okay. Then second type of diffraction grating is the reflective grating. Now when we are going to take the metal plate which is a reflective in nature, which is having good reflective surface, and we are plotting n number of parallel grooves on that metal plate, then it will be called as a reflective grating. Now again here the constructive and destructive interference will be observed due to the diffraction of the light, and the polychromatic light can be converted into monochromatic light. Okay, this is what the transmittive grating, and this is what the reflective grating. So here in case of transmittive grating, the light can pass through it and you will get the dispersion of the light, while in case of the reflective grating, the light will get reflected, will get the constructive and destructive interference, and will get the separation of light from the polychromatic source of light. Now sample cell and sample holder is the next component of this single beam UV visible spectrophotometer. It is a device which is having thickness around 1 centimeter, and either it is made up of a glass or it is made up of a quartz. It is a sample holder which is either cylindrical in nature or it may be a rectangular in nature. So in sample holder we can have a sample or we can have a solution of the analyte in specific solvent. Okay. Then the sample cell or sample holder is placed inside the instrument in a certain grooves through which the light can pass. The monochromatic light obtained from the monochromatic can be passed. In this case, if we are using the colored solution for analysis, then the glass sample cell or sample holder can be used, and if you are using the transparent solution, colorless solution, in that case the quad can be used, or quartz sample cell can be used. Further, detector. In spectrophotometer, on any kind of spectrophotometer, the detector used are the devices which will convert the light energy into electrical energy. Hence it is called as a transducers. It is called as a transducer. So detector is the device that will convert the light energy into electrical signal. Now several types of detectors that are used in the single beam spectrophotometer: photovoltaic cell, phototube, photomultiplier tube, that can be used in the single beam spectrophotometer. Out of that we will discuss about the phototube. Now phototube is a device, we'll go to the next slide, that is the diagram of the phototube. You can see this, that phototube is a device which is consisting of a evacuated glass bulb or glass tube. So this is what the evacuated glass bulb or glass tube. Now in this evacuated glass bulb, which is having vacuum inside, there is a half cylindrical cathode. So this half cylindrical cathode is coated from the inside by using the photosensitive material. The photosensitive material used here may be cesium oxide or potassium oxide. There is one anode which is made up of a metal which is placed in front of this detector. Now whenever the light passes through the sample, the part of the light will get absorbed and the part of light will get transmitted. That transmitted light will fall on this half cylinder, on the inner wall of this half cylinder. Now due to this, it will emit the electron, and that emitted electron will be captured by this anode and it will give us the electrical signal. That electrical signal will get converted into, first it will amplified and then it will get converted into the spectral data. Now here amplifier will be used to amplify the electrical signal, while readout device will convert the that electrical signal into the spectrophotometric data or spectroscopic data. Now here the spectroscopic data will be with the wavelength and the either absorption or transmission. That is what the component of the single beam spectrophotometer. Thank you.